2008, number 6. I've already jotted down a couple things. I've jotted down the f of x, the derivative, and the domain, which is all given to us. So let's see here. Part A, write the equation of a line tangent to the graph at x equals, let's see, x equals e squared. So the equation of a tangent line, y minus f of x, or in this case, f of e squared equals f prime of e squared times x minus e squared. Now remember, we don't have a calculator for any of this. So first thing I gotta do is I have to find f of e squared. So f of e squared is going to equal ln of e squared over e squared. And in this case, let's see, ln of e, that cancels, so I've got 2 over e squared. And now I need f prime of e squared. So f prime of e squared will be 1 minus ln of e squared all over e squared squared. So that's going to be a 1 minus ln of e cancels, so 1 minus 2, so that's going to be a negative 1 over e to the 4th. So negative 1 over e to the 4th times x minus e squared. So there's the equation of the tangent line that they asked me for in part A. Not too bad. Part B. Find the x-coordinate of the critical point, determine whether it's a min, max, or neither, and justify. So a critical point means f prime is 0 or d n e. However, in this case, if I'm looking at these equations, f prime is going to be d n e when x is 0, because that will turn my denominator into a 0. And of course, I can't put a 0 into an ln, or a negative number. However, that's why they gave me that domain. I know that x is greater than 0. So if that's true, if x is some positive number, then that will never be d n e, because ln will always exist and my denominator will never be 0. So all I need to worry about is, when does my derivative equal 0? Because I don't have to worry about the d n e, so that's really nice. Well, a fraction is equal to 0 when the top is equal to 0. So let's see here. If I add this over, I have ln of x is equal to 1. Drop the base, e to the first is x, so that means x equals e. So that's where my critical point is, but now I have to determine whether that's a max or a min or neither. So I'm going to make my f prime number line, and I'm going to start it at 0 because my domain again is x is greater than 0. And I'm going to put e on here. So I want to pick a number in between 0 and e that I can sub into my derivative to see if it's positive or negative. Let's pick a nice easy number. Let's use 1. Remember, e is about 2.7. So 1 is a good number to pick. If I sub 1 into my derivative, then I would have 1 minus ln of 1, which is 0. So 1 minus 0 is 1 over 1 squared. That's going to be positive. Now, what about a number bigger than e? How about e squared? And the reason I'm picking that one is because we actually used it up here in part A. I already know that the derivative of e squared, which has to be bigger than e, is a negative number. We already found that out. Therefore, f is increasing and then decreasing. F has a max at x equals e, because f prime is 0, and we have a sign change of plus 2 minus. So there's part B. Not bad. Part C. The graph has exactly 1 point of inflection. Find the x-coordinate of this point. An inflection point is when the second derivative is 0 or d n e and has a sign change. So this is my thought here. An inflection point, f double prime, 0 or d n e, and sign change. So here I go. To find the second derivative, that's going to require a little quotient rule for us. So remember, here's my first derivative right up here. Second derivative, ho x squared d high. The derivative of the top, the derivative of 1 is 0 minus ln of x. The derivative of ln of x is a negative 1 over x. Well, the derivative of ln of x is a positive 1 over x, but that negative right there is going to make this negative as well. So ho d high minus high d ho all over ho ho. So that's x squared squared, which is x to the fourth. I'm going to do some simplifying here. So f double prime of x is equal to, this is going to turn into a negative x. If I distribute the negative and the 2x, I'm going to get minus 2x plus 2x ln of x all over x to the fourth. Keep cleaning that up. I want this as easy as possible. Negative 3x plus 2x ln of x over x to the fourth. Okay, I think I can do a little bit better than that. So I'm going to keep simplifying this. And let's see what I can get here. I can take an x out of everything. So I would have f double prime of x is equal to negative 3 plus 2 ln of x over x to the third. Now what I can do here is I know that f double prime will be d and e once again if x is 0, which I don't have to worry about because x has to be greater than 0. That was given to me. That's my domain. So when does this equation, negative 3 plus 2 ln of x over x to the third, equal 0? It will never be d and e, so that's good. So when does a fraction equal 0? When the top is 0. I'm going to add the 3 over, divide, and drop the base. E to the 3 halves is equal to x. And then I think I have my critical point. I just want to verify that I have a sign change. F double prime number line, I'm going to throw a 0 on there. And I'm going to throw e to the 3 halves on there. And I'm going to look at a number. Let's see here. What's a good number in between 0 and e to the 3 halves? I don't know. How about just e to the first? If I sub e into my second derivative, negative 3 plus 2 ln of e, well, ln of e is 1. So negative 3 plus 2 is going to be a negative number on top. And then I have a positive number getting cubed, so that denominator is going to be positive. So that's going to end up as a negative. Negative on top, positive on the bottom, overall is negative. And a number bigger than e to the 3 halves, well, that's e to the 1.5. That's my exponent. Pick a bigger exponent. E squared is bigger because it's got a bigger exponent. So when I sub an e squared to the second derivative, I end up with negative 3 plus 2 ln of e squared. Those cancel. So I end up with negative 3 plus 4 on top of my fraction over a positive number. Because I have a positive number and I'm cubing it, it's still going to be positive. So positive over positive is positive. So therefore, I definitely have a sign change. My critical point, x equals e to the 3 halves. Now, for the final step, I have to find the limit as x approaches 0 from the right of f of x, which is ln of x over x. So now, this is a little tricky. I have to think about my graph and what it looks like, and I have to think about what happens when I approach 0 from the right. Well, if I want to think about the graph of ln of x over x, that's going to require the fabulous 5-point plan. My domain is x is greater than 0. That was given to me. My intercept, if x is 0 or if y is 0. Well, if x is 0, that doesn't exist. If y is 0, then that means that this whole equation is 0, and that's going to happen when when x is 1, because ln of 1 is 0. So there's my intercept. My VA, I know that I have a VA when x equals 0. That's my x-axis. I can't have 0 because that would make the denominator 0. I also can't go past 0 because that would get me into negative numbers, which I also can't have here. My HA. And this is kind of the key to this whole thing. I need to look at the limit as x approaches positive infinity and as x approaches negative infinity. Well, I know that x can't approach negative infinity because I can't go into those negative numbers. And as x approaches positive infinity, I want to look at ln of infinity over infinity. What is getting bigger faster? The bottom. Therefore, the limit is 0. And finally, I want to look at the shading on this. Shade the Badlands. What makes the top 0? 1, that goes on my number line. What makes the bottom 0? 0, that would go on my number line. I'm kind of cutting this off again at 0 because I can only deal with positive numbers. If I pick a number in between, let's see here. What if I pick 1/2? ln of 1/2 is a negative number because this is ln of x. That's my graph for ln of x. This right here is 1. ln of 1/2 is going to be a negative over a positive, so that's going to be negative. And then ln of, I don't know, what about e? That's bigger. That's going to be a positive number over a positive number, so that's going to be positive. When I get myself a little graph here, there's 1. Let's see here. My shading, when x is less than 1, my graph is down here. So I'm shading the Badlands. When x is greater than 1, my graph is positive. And then I have a horizontal asymptote at 0 as I go to positive infinity. My graph with my intercept, I'm going to go up, bump it, and come back down. Now, the whole reason I'm doing all this is to find out what happens when I approach 0 from the right side. As I approach 0 from the right side, what's happening to my graph? It is headed towards negative infinity. That is the answer to part D. It seems like a lot of work, but it kind of brings it all together. That 5-point plan should not take too long. Just because some of the information was given to us, it's really the shading the Badlands that you want to focus on, the limits that you want to focus on to kind of see what's happening to that graph. All right, hope that went well.